Hello, my name is Taylor Ross. I'm the owner of Frustum Virtual in Los Angeles, California. In this tutorial, I'll be going over placement and anti-latency service. Placement can be thought of as an additional transformation of the tracking data that depends on the ALT's position relative to the pivot point of the object the ALT is mounted to. In virtual production, we're referring to a camera's nodal point. A camera's nodal point coincides with the lens's optical center. The optical center is the point within the lens where the light rays passing through the lens remain undeviated. In other words, if a ray of light enters the lens and passes through its optical center, it continues along the same path without any angular deviation. To create the perfect parallax on a zoom lens in virtual production, you should create a placement for the main focal length in anti-latency service, and then do the calibration for different focal lengths inside Ximetry or Unreal Engine. In this tutorial, I will be calibrating the placement of a prime lens, but just note that if you're using a zoom lens, there may be additional steps. To attach the ALT to the camera, choose a convenient location on the camera body. When you're choosing the location of the socket with the ALT, there's a few things that you're going to want to take into consideration. The ALT tracker should be pointed towards the IR markers of the anti-latency tracking area. For the placement in this example, I'm using the anti-latency pillars. To make it easier to measure the X, Y, and Z offsets, position the tracker's center along one of the X, Y, and Z axis relative to the camera's pivot point. For virtual production, the camera's pivot point is the lens's optical center. If possible, the ALT tracker should be rotated to a position with maximum field of view. Make sure that the ALT has a clear view of the IR markers for your anti-latency tracking volume, and that none of the elements of the camera that you're working with are interfering with the field of view of the ALT. The ALT lens has a field of view of 230 degrees horizontally and 180 degrees vertically. The ALT tracker's pivot point is located 2.62 millimeters from its backside. The offset between the ALT's pivot point and the virtual production socket's backside is 5.71 millimeters. We will need to take this into account when inputting our values in anti-latency service. On the anti-latency virtual production socket, the ALT's offset is represented by this little cross. I've already measured the offset between my camera's nodal point and my anti-latency tracker. The values for my placement are 7 centimeters on the z-axis and 14.5 centimeters on the y-axis. Now I will show you how to input these values in anti-latency service. Navigate to anti-latency service and open it. In the upper left-hand corner, navigate to the Placements tab. You can create a new placement by selecting this plus sign in the bottom right-hand corner. Here you will have the option to create a custom placement. For this tutorial, I'm just going to edit a custom placement that I've already created. I will select the 3 dots and then select Edit. You can see the anti-latency device represented by this green outline. In this custom placement, my anti-latency device is placed at the 0 point. The only thing that I've updated is the rotation on the z-axis. I've changed this to 180 degrees because my anti-latency device is upside down. Right-click in the viewport to orbit. Use your middle mouse button to move around. Down at the bottom, we have the options to select front, right, or top to change the view. I'm going to select right to go into a profile view. Now I will input the offset of my ALT tracker. For the Y, I will input negative 14.5. Inputting a negative value will move my ALT down 14.5 centimeters. Now I will input a value of 7 on the Z-axis. This will move the position of my ALT 7 centimeters forward. You can now see a much more accurate representation of my camera's nodal point and the placement of my ALT tracker. Now that I've specified the offset between my camera's nodal point and my ALT tracker, I can select Save in the upper right-hand corner, and then I can use the back arrow in the upper left-hand corner. With this new custom offset saved, we want to make sure that it's set as the default. Select the 3 dots next to your custom placement and select Set as Default. This will be represented by the blue check mark in the upper right-hand corner of your placement. You can now close anti-latency service. Now when you're using anti-latency as a camera tracking device in Unreal Engine or Ximetry, the offset will already be correct. Hopefully this video was helpful in explaining placement for anti-latency service. Be sure to like and subscribe for more videos, and thanks for watching.